Welcome to the next section. We're going to take a look at the law of cosines. Now, some people really get hung up on, oh, you use law of sines here and you use law of cosines there. What I would encourage you, the law of sines typically is easier to use. We are solving triangles. And so basically, when you get into a situation and you're trying to solve the triangle, just look at it and say, can I do the law of sines? Well, if you look here, you see you don't have any pairs. You've got side C, but you don't have angle C, and you can't find angle C. You also have side A, but no angle A, and again, you can't find angle A. And you've got angle B, but you don't have side B. And so law of sines isn't going to work here. So there is a rule called law of cosines. One advantage of law of cosines, it can be used in any triangle, just like the law of sines. The textbook gives you 3 different equations for law of sines, and I think this is kind of complicated, and we're going to try to simplify it here. If you look at this, you'll notice we've got sides here, right? Side a squared equals b squared plus c squared. Or you might be more familiar with this one, a squared plus b squared equals c squared, kind of like Pythagorean theorem. In fact, Pythagorean theorem is a special case of this. What I would encourage you is to notice something, a little trick here. What do you notice here? Okay. Whatever goes here, this side has to match this opposite angle. And as long as you remember that, the rest of the formula kind of falls into place. You see we have BC, then we also have BC here. So whatever is in these 2 locations ends up going here as well. AC, AC, AB, AB. And then the minus 2, the cosine's the same. So let's just try that out. Okay, we already looked at this. We already said law of sines isn't going to work, so we're going to have to use the law of cosines. Now, how do I set it up? What side do I put in and which angle do I put in? It's not going to matter. You can really pick any of them that you want. And so I'm just going to go ahead and put, I don't know. I don't want to solve. So I'm going to put B on the left side. See what I'm saying? If I put b squared there, then I know the rest of it. I'm going to have c squared and a squared, those are numbers, minus 2 times a times c, those are numbers, times the cosine of b, that's a number. You could have used any of them and solved. So I've got the one side, now I need the other 2 sides, 32 squared plus 48 squared minus 2 times 32 times 48 times the cosine of angle B, 125.2. All right. If you take a look, probably one mistake that I often see students making is they try to plug all of this into the calculator. Nope, never mind. Ignore that. Here we can. We can just type this all into the calculator. We get b squared equals 5,098.8. Square root both sides, and we find that the length of B is 71.4. So we now know, maybe I'll write that in a different color, that B is 71.4. And now we need to find the angle A and angle C. Any thoughts on how to do that? Maybe you said use the law of cosines again. And you're right, we could use the law of cosines again. However, you could use the law of sines here. Now that we have a pair, we have an angle and a side and an angle, the law of sines is going to work pretty good here. We have 71.4 divided by the sine of 125.2 equals, I'll go ahead and find A, 32 over the sine of A. So we can then set that up, cross multiply and divide. I don't have that number written down, but then we can do the inverse sine, and we can find that angle A equals 21.5 degrees. And once we know that, we can find angle C. We have two of the three angles in the triangle. So 180 minus 21.5 minus 125.2. And when we do that, I better check my work here. I think I'm getting 33.3 degrees. Double check my work on the calculator. The idea holds. So just do a quick review here before I close out. So law of cosines is again used to solve triangles. You can use it for any triangle. Recognize that whatever side you put here, that opposite angle needs to go here. Okay? And so for this triangle, we set it up. I didn't know B, side B, and so I put all the other information in here. A, C, cosine of B. Simplified all this, took the square root, and got little b. I then set up a law of sines, cross multiply, divide, took the arc sine or the inverse sine to get 21.5. Then I took 180. I now have two triangle angles, right? A and B, need to find C. So I just take 180, all three angles in the triangle, and subtract 21.5 and 125.2. That leaves me with 33.3 degrees. So, final answer, angle C, angle A, and side B.